Okay, so we are moving on with scalar of a vector. Scalar of a vector. The scalar of a vector. Now I've already dealt with scalar, but I've not mentioned it because it's a very simple subtopic. Let me just mention it and then we know how to go about it. Now when we are talking about the scalar of a vector, we are looking at the numbers, or should I say terms, with which we use to what? Multiply the vector. For instance, we usually represent it as k, so that if we have pq as a vector, and then we are looking for the scalar, which is kpq, it simply means that we are going to multiply the k by the values or the x and y coordinates, and then this is going to become kx and then ky, and that is it. So kpq okay, so kpq gives us that. Now this is with the component form. This is with the component form. So then we are going to look at how to deal with the scalar with the magnitude bearing form. That one is quite difficult. It's not difficult, but it's quite lengthier than this. Okay, now let's see. When we have, before I move on to that, when we have uv to be say 3, 7, and we are asked to find say 2uv, then this is going to be 2, 3, 7, like that, which will now become 6, 14. That is to say that 2 times 3 gives us 6, and then 2 times 7 gives us what? 14. It's as simple as that. So it means that the scalar multiplies both values in the bracket. Okay, let's take another one. Let's say they're asking us to find 3 over, let's make it 2 over 3 uv. Then this one is going to, this is where people usually make mistakes. Instead of them multiplying the 2 over 3 by both values, they multiply the 2 by 3 and they multiply 3 by 7, which is totally wrong. They are supposed to multiply both, the whole of the fraction, by 3. So it is going to be 2 over 3 by 3 and then 2 over 3 by 7. Okay, then this will now become 2 over 3 by 3 gives us 2, and then 2 over 3 by 7 gives us 14 over 3. That is the outcome for that particular question. Okay, now let me look at how to deal with the magnitude bearing form of it. Then we can take a question on that. Let's say we have vector GH. Okay, vector GH to be 3 centimeters and then 125 degrees, and we are asked to find 15 GH, 15 vector GH. How is this going to be done? Now in this case it is going to be 15 GH is going to, I told you in the previous thing we just did that is when we're dealing with the negative of a vector, I chipped in a little of this. I told you that when we are having a number multiplying the magnitude bearing form of a vector, it means that the number is only affecting the distance. It can't affect the direction. So the number affects the distance, and then the negative affects the direction. In this case, we are dealing with only the number. So then this one is going to be 15 times 3, and then 125 degrees. So then this is going to be 45, and then 45 centimeters, and then 125 degrees. As simple as that. Okay? But then if we are dealing with the one involving a scalar that involves a negative number, then this is going to be like that. Assuming we have minus 6 over 5, or minus 6 over minus 3 over 2. Okay, let's do this. Minus 2 over 3 GH. Then this is now going to be, you see, this time around you realize there's a negative there. The negative will affect the direction, while the number affects the what? The distance. So then this is how it goes. Like, it is going to be 2 over 3 times 3 centimeters, and then you see this number here, the bearing is less than 180 degrees, so it means you are going to add 180 to it. So it's going to be 125 degrees plus 180 degrees, and that is going to be, this goes there 1, so we have 2 centimeters, and then 125 plus 180 is 305 degrees, and that is your outcome. So the difference between this and that is quite huge, because there are two different things. This one, just go with the component form, you just multiply whatever is there to whatever you have as the vector. But then with the distance direction form, or the magnitude bearing form, this is how you go about it. When it's a negative number, it affects both of them. But if it is a positive number, it only affects the distance. If the number is negative, it affects both distance and then bearing. But if it is a positive number, then it affects only the distance without affecting the bearing. Okay, now let's take some questions on that. Let's take some questions on that. So take note of the following question. If vector AB is equal to 4, 2, comma, find, okay, if vector AB is equal to 4, 2, and PR, and vector PR is equal to 6 centimeters and then 210 degrees, comma, find I. 3 vector PR I minus 3 vector AB I 1 over 2 AB IV 1 over 3 PR V minus 2 PR and then VI minus 1 over 2 PR. Okay, as you can see, the question is very simple and straightforward. The question is very simple and then straightforward. I'm going to solve 2 out of all these, and the rest are yours to solve by yourselves whenever you are free. All right, so let's go through this quickly, and then we see the way forward. Now the first one, the question itself is this. We are told that vector AB is 4, 2, and then vector PR is 6 centimeters, and then 2, 10 degrees. We are asked to find I, 3PR. Okay, I'm going to choose II. I'm going to choose II, and then I'll choose V. So I'm going to choose these 2 questions. The rest, okay, I'll choose II and then VI. So I'll choose these 2 questions. The rest you do them by yourselves. So II, we have minus 3AB, and then minus 3AB means minus 3. The AB is what? 4, 2. So then this is going to be minus 3 times 4 is minus 12. Minus 3 times 2 is minus 6. Alright, so that we say, therefore, minus 3AB is equal to that. Let's take the VI. VI is minus half PR. Alright, and we know the PR as this. As that, isn't it? So if that is the case, then since it is what? A magnitude direction form, it means we are going to apply the magnitude direction form of it. Okay, so half means we are going to change this, and then the 1/2 means we are going to multiply half by the 6. So then it's going to become 1/2 times 6 centimeters, and then 210 minus 180. Why did we subtract 180 degrees from it? It is because the number here is bigger than 180, so we subtract 180 from it. With the previous example, we realized that we added 180 to it because the number was less than 180. Okay, so then this becomes so half of 6 is 3 centimeters, and then 210 minus 180 is 30 degrees. So you write it in 3 digits. You say 030 degrees. So it's as simple as that. So you do the rest by yourselves. Okay, so with that dealt with, we are going to move on to converting a vector in components from 2 magnitude bearing form. So converting a vector to magnitude bearing form. Okay, we have to go through a few steps to do that. There are actually 2 procedures we can take. There are actually 2 procedures we can take. There are actually 2 procedures we can take. One of them being the fact that you know exactly how to deal with the quadrant within which you find the bearing. And then the other one is reading it off from the quadrant. Okay, I'll show you how to go through that procedure. And then some people prefer actually memorizing it, which I don't think is the best. Personally, I don't think that is the best. So then I'm going to show you how it is read, and then you take note of it. So this is what I'm going to take note of. This is what we're going to take note of. Remember when we went through the all silly tongue cuts, and then how it is done? We are going to do a similar one, but it's a little different from that. So this is our y, and that is our x degrees. Now, most often we are going to be dealing with the quadrants, and most often, like I said from the first part when we started, all the time we are going to make the triangle with the x axis. Okay, but let's forget about the triangle for now, and then we move on. Now, from here to the vector, you know that this one is the vector given. Okay, let's say vector a, b. Are you getting it? I'll be taking off the a, but I just want you to understand. Let's say this is vector ab. I told you the bearing is always from the geometric north. Okay, but for now, let's just deal with this as though it was just y and then x. So I'll talk about the fact that the bearing is always from the positive y axis. So then, if that is the case, the angle that we can find will always be in the right angle created. So if this is the right angle created, we can always find this. If we find this, that is not what we are looking for. We will always be looking for the bearing from here to here. All right, that is from the positive y-axis. So then in this case, this is what we are looking for, theta. So I will be using alpha as the value in the, or as the angle in the triangle, and then theta as the bearing. Okay, the bearing, in other words, the angle from the positive y-axis to the vector given. Okay, good. So now if this is the alpha, and then this is the theta, we realize that this is the quadrant, and in every quadrant, you know, there is what, 90 degrees. If that is the case, then if we have alpha and we subtract alpha from 90 degrees, we get theta. I believe you agree with me. So in this case, it is going to be, to get theta, theta is going to be 90 minus alpha. There's no need memorizing this. When you listen to this carefully and then you follow, you realize that you can easily get your values instead of memorizing it. Because you memorize them, you can actually get confused eventually. All right. Now, in the second quadrant, like I said earlier, it is going to be like that. You read off, you make your triangle with the what? With the x-axis. So then this becomes your alpha. And then the theta you are looking for, so let me put this here so it doesn't interfere with mine. So theta is going to be equal to 90 minus alpha. So the theta we are looking for, actually the bearing we are looking for is like that, from here to here. So that becomes theta. Okay, now we can easily get alpha, but we realize that we know the whole of this angle, isn't it? Because we are looking for this, and this angle is part of what we are looking for. If that is the case, then we know that this angle is 90 degrees. If we add this angle that we have been able to find to this, we will get the whole of the bearing we are looking for. So in other words, we say that theta is equal to 90 plus alpha in the second quadrant. So in the fourth quadrant, this is the first quadrant. This is the fourth quadrant. Now let's move on to the third quadrant. All right. Once again, we can get alpha. Okay, that is the angle created in the triangle. Okay, in other words, the angle that is made with the x-axis. But that's not what we are looking for. We are actually looking for the bearing from the positive y-axis. In other words, we are looking for the value from the geometric north. Okay, so if that is the case, we say that is the what? The theta. So from here all the way to the vector line is the theta. Now as you can see, we have the alpha. That is to say, in every single question you can readily find the alpha. What you can't easily find is the theta. In other words, the theta or the bearing is dependent on the alpha here. In other words, the angle created by the x-axis. Okay, so now we realize that we have 90 degrees, we have 180 degrees, we have 270 degrees. Someone will say, if that is the case, then let's add alpha to the whole of this. What you don't realize is the fact that, you see, we don't have this small space, so we can't use that. What then must we do? Realize that we have the whole of this from here to here to be 270, because you know the whole length from here to here is 90. The whole distance from, the whole bearing from here to here, you know this is 90, this is 180, this is 270. Okay, if we subtract this angle created here that we have been able to find, if we subtract it from 270, then we'll get the whole of that. Are you getting it? So we say that theta is equal to, so this is a third quadrant. Alright, so theta is going to be equal to 270 degrees minus alpha in the third quadrant. Now let's move on to the second quadrant. Once again, we have the vector line, and then it is creating a triangle with the x-axis. So the angle created in the triangle is alpha. But what we are looking for is actually this, okay? So all the way from the positive y-axis. So that becomes our theta. Let me do it a little better. Okay, that is a theta, and that is what we are looking for. Now, as you can see, we can readily find the alpha, okay? And then we have the whole of this bearing to be what? 270. We know from here to here to there and to there is 270. If we just add this small angle we have found to the 270, we have found the whole of that bearing. Okay, so if that is the case, then it means that in the second quadrant, so this one is going to be theta equals 270 degrees plus alpha. Okay, so we add alpha to the whole of that 270. So that is what we are going to look at. With this understood, with the explanation I have given here, when you follow, you realize that the explanation I'm going to give to the question that will follow next will be quite easier. You will understand it better. Okay, so study that diagram very well, and let's look at the next question.